So there are some special products for polynomials, and product means multiplication problems, that there is no work required to be shown to come up with the answer. So I'm going to show you where the patterns come from, and I would recommend that you memorize these patterns so that you can save some time doing some of these binomial products. The first one is the square of a binomial. For example, a plus b squared. And something squared is that something times itself. Okay? What I'm going to do is, from multiplication video, you know that I can do this work by the FOIL method. So that's what I'm going to do. So I'm going to do my first, outer, inner, and last. A times A is A squared. Outer, A times B is AB. Inner, B times A is BA, which is the same as AB due to the commutative property. And then B times B is B squared. And I combine my two middle terms. I have one of something plus another of that something. 1 plus 1 is 2 of those somethings. So I get this as my pattern. When I do the square of a difference, I do the same thing, and I'm going to come up with the answer. Then I'm going to tell you what words will help you memorize what the pattern is so you can go directly from the problem to the answer. So a minus b squared is a minus b times a minus b. Again, I'm going to FOIL it. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ba, which is the same as negative ab. And negative b times negative b is a positive b squared. Combining the middle terms, negative 1 of something minus another of that something is negative 1 minus 1, which is negative 2 of those somethings, plus b squared. So the pattern in words to come up with the answer is, notice I have a's and b's in both of these. So my first term is the first term squared. So a binomial squared. In your notes, you must write down this sentence that I'm writing down. A binomial squared is has 3 terms, so it's a trinomial. The first term is the first term squared. The last term is the last term squared. The middle term is 2 times their product. Anytime I am squaring a binomial in class, these are the exact same words I will say every single time. I expect you to memorize this sentence, okay, and be able to write it out in words and to be able to use it from the words to come up with your answer. So again, the words are: a binomial squared is a trinomial. The first term is the first term squared. The last term is the last term squared. The middle term is 2 times the product. So I'm going to do a couple of examples using the sentence to come up with the answer. So the square of a binomial, doing this, let's do 2x minus 3 squared. A binomial squared is a trinomial. The first term is the first term squared, 4x squared. The last term is the last term squared, which is negative 3 times negative 3, which is a positive 9. The middle term is 2 times the product, 2 times 2x times negative 3. 2 times 2 is 4, times negative 3 is negative 12, x plus 9. You do not need to show this intermediate step as long as you can come up with the correct answer by doing it all in your head. And the way I do it is I go, this number times this number is negative 6, times 2 is negative 12 with the x there. Okay? You may end up with more than one variable. So, for example, 3x plus 2y squared. A binomial squared is a trinomial. The first term is the first term squared. 3x times 3x is 9x squared. The last term is the last term squared. 2y times 2y is 4y squared. And the middle term is 2 times the product. 3 times 2 is 6, times 2 is 12, and then x times y. Okay, so that's how you would do a square of a binomial. That's our first memorized pattern. Our second memorized pattern is called the difference of squares. And it's anything in the form of a binomial times the same first and second term, but with an opposite sign inside of it. Okay, what I'm going to do is I'm going to FOIL this out, and then we're going to write down what the special pattern is and do a couple examples. So to FOIL it out, I get a times a, which is a squared. Outer is a times negative b, which is negative ab. Inner is b times a, which is ab. And last is b times negative b, which is negative b squared. Combining the like terms, something minus itself is 0, so that just disappears. And I'm left with a squared minus b squared. So the words here, the difference of squares, difference of squares is a binomial. It's the first term squared minus, always, the last term squared. You may have already had a class where if I have a binomial and the only difference between another binomial and it is the sign that's in between the two terms, these are conjugates of each other. Okay, and there are a lot of times that I end up multiplying conjugates together. Okay, so it's always going to be the first term squared minus the last term squared. Example, 2x plus 4 times its conjugate, which would be 2x minus 4, is equal to the first term squared, 2x times 2x is 4x squared, minus the last term squared. 4 times 4 is 16. 3 plus the square root of 2 times 3 minus the square root of 2 is equal to the first term squared, 9, minus the last term squared. Square root of 2 times the square root of 2 is just 2, which would just be 7. Notice that this is actually would be a monomial times a monomial, but it's a way that I can use that polynomial special pattern to simplify this multiplication problem. Okay, and if you've already done simplifying radicals, you've already seen this method for rationalizing denominators of radicals. So those are our first two polynomial special products. If you are in 8th grade math, Algebra 1, or geometry, you can stop the video right now. If you are in Algebra 2 or college algebra, we need to continue for our next pattern. So our next pattern is a binomial cubed. For example, a plus b cubed. What I want you to realize is a plus b cubed is the same thing as a plus b squared times a plus b. Okay, we already know what a plus b squared is because a binomial squared is a trinomial. The first term is the first term squared. The last term is the last term squared. The middle term is 2 times the product. So what I'm going to do now is I'm going to do the one more multiplication. Okay. Again, this is not the way I want you to do something cubed. I'm going to show you the shortcut once we're deriving the shortcut right now. So I'm going to use the distributive property. I'm going to do a times everything in here. A times a squared is a cubed. A times 2ab is 2a squared b. A times b squared is ab squared. B times a squared is a squared b. B times 2ab is 2ab squared. And b times b cubed is b times b squared is b cubed. Okay. I'm going to add these up, and I get a cubed plus 2 of something plus 1 of something is 3 of that something. 1 of something plus 2 of something is 3 of that something. And then I have the b cubed. Okay? I now have, if I have a binomial cubed, this is the pattern that I'm always going to have. Okay? And here's the way I want you to think about it. I have 3 numbers. I'm going to put them, 4 numbers. 1, 3, 3, 1. 1, 3, 3, 1. Okay? This first term is going to be multiplied by something cubed, then something squared, then something to the first. This last one I'm going to have multiplied by something cubed, something squared, and then something to the first. Okay, and all of those things get added together. This is the pattern. Okay, and this is one of the times in your notes that I would recommend that you either use colored pencils or pens that have different colors so that you can write this pattern down. Okay, if you watch the prime number videos or the squaring videos, coming up with squares and square roots, I showed you a triangle where the left-hand side and the right-hand side of the triangle is 1s. The middle of the triangle are the sum of the things above it. So 1 plus 2 is 3. 2 plus 1 is 3. this is part of what's called the binomial theorem, that I can use what's called Pascal's triangle to come up with the numbers that go in front of each of my terms for a binomial to any power. This would be my binomial to the 0th power. Anything to the 0th except for 0 is 1. A binomial to the 1st power. The first term would have a coefficient of 1. The second one would have a coefficient of 1 times whatever that term is. A binomial squared. 1, 2, 1. 1, 2, 1. A binomial cubed. 1, 3, 3, 1. 1, 3, 3, 1. When you get to college algebra and the second part of Algebra 2, we can continue this. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. And we can keep on continuing for various powers. Now what I want you to notice is the degree here is the same as this one. And it goes down by 1 each time. The degree on the right-hand side for my last term starts at the top one and goes down each time I go to the left. I'm going to do 2 examples of cubing a binomial. Okay? If you cannot do this pattern, I have no problems with you rewriting it like this and then using the distributive property to come up with the cubing. However, it's going to take a lot of extra time for you to do it that way. Okay? So what I'm going to do is I'm going to rewrite this pattern up here, and then I'm going to do the 2 examples. So that is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. 2x minus 3 cubed. The way I always write this out is I always put parentheses and I just write my generic problem. So I put parentheses and I put the coefficients. I don't put the 1s down, I just put the 2 3s there. And now I'm going to fill in the blanks. 2x, the first term, starts the first power, third power, second power, first power. My negative 3 goes here. And now I'm going to do the individual multiplications to come up with my final answer. 2 cubed is 8. X cubed. 2 squared is 4. 4 times 3 is 12. X squared is x squared. That number is going to be multiplied by negative 3. Negative 3 squared is 9. 9 times 2 is 18. Actually, let's do it this way. 9 times 3 is 27, times 2 is 54, and 54 times x is 54x. Negative 3 cubed, negative 3 times negative 3 is 9, times negative 3 is negative 27. In this middle term, I do need to do this multiplication. 8x cubed minus 36x squared plus 54x minus 27. Okay, notice my final answer does not have 1s, 3s, and 1s in it. That got taken into account when I did the multiplication of everything that was in here. Okay, so the 1, 3, 3, 1 is part of what I multiply each term by. Okay, notice if you have a negative something to the third power, you're going to alternate plus, minus, plus, minus. Okay, that's one way you can check your work there. The second example I'm going to do notice that I'm going to use the exact same set of parentheses again. Okay? And this time I'll put a plus sign in between the two. 3x plus, let's just do y cubed. Okay, so I've got the 1, 3, 3, 1 in front of what I'm going to do my pattern. In the first boxes, I put my first term to the third, to the second, to the first. In my last boxes, I put the last term, y, y, y. And now I do the work. 3 cubed, 27. X cubed. 3 squared is 9. 9 times 3 is 27. X squared, y. 3 times 3 is 9. X, y squared plus y cubed. So again, in Algebra 2, that's the most that I'm going to have you do with patterns until the end of the year. Okay, at the end of the year, you're going to have to be able to tell me what the coefficient is for the 10th term in a binomial like to the 12th power. And again, there will be a separate video where I'm going to go over, starting with this cubing pattern, going to polynomials of higher degrees. Okay, so this is the roughest one for a memorized pattern. But if you can't memorize that pattern, remember it's something cubed is something squared times that something. Then you can do write down what that something squared is, multiply it out, and then you can come up with your final answer. But that will take more work than using the shortcut.